Good morning and welcome back to the Nexperia Power Live Industrial channel, and a very warm welcome to our special guests Instagrid, who are here to discuss their innovations in the world's most advanced power supply technology. So this final session is scheduled for approximately 25 minutes. As before, we'll begin with an introduction and then open the floor for questions. So please do join in. You can ask any questions to the Instagrid team throughout the session by using the orange speech bubble in the bottom right of your screen. So before I hand over to the Instagrid team, let's take a small look at what we're here to discuss with this short video.
Hi everyone, I'm Sebastian and I'm one of the co-founders of Instagrid. At Instagrid, we make portable battery power supplies for professionals. We make sure that professionals working on construction sites, in gardening, and in many more applications outside have a reliable source of electricity throughout their workday. What is even more important is that they can rely on a clean source of energy without having to turn to diesel generators or other polluting sources to generate electricity on site. So this little unit here is actually the most advanced portable battery supply in the world. It delivers uncompromised grid quality power at 16 amps, 3600 watts, meaning you don't have to worry at all what you plug in. Also, it was really made for professionals, meaning it is really robust. It weighs just about 15 kilograms, it's waterproof, it's absolutely silent, and it has enough energy to support you throughout your entire workday. How did we do that? Well, our unique technology breaks down the big battery into a lot of small batteries. Each one of these little small units here is really smart. It has its own microprocessor, battery management, and its own power converter, meaning that we get the same type of advantages as in other applications where you break down big technological problems into smaller problems. You can compare that to the internet, where the performance is provided by millions and millions of small servers that all form a smart network. At Instagrid, we really care about making extremely robust solutions. To do that, we have to make sure that all of the components that are inside are also robust. We had to take special care of the MOSFETs in there because we have about 100 of these. So we chose Nexperia LF pack because, coming from a big automotive OEM, we experienced in the past that their reliability is just superior in harsh environments. What we also liked about our work with Nexperia is how we could work with them from the start on eye level. Instagrid is just about 2 years old, but really from the days when we were just a two-person startup, we could discuss anything with them. We would get great support, and we still get it today when we're preparing our mass production. If you want to learn more about our units, about our power supplies, please visit instagrid.co.
Really nice video and a very nice, exciting technology. It's my pleasure to introduce Jakob and Andreas from the Instagrid team. So with that, I'll hand over to Jakob to explain more.
Thanks for the introduction, Kelly, and welcome to everyone who has tuned in. My name is Jakob, and today I want to introduce to you Instagrid, a company that basically from the beginning on has worked together with Nexperia, and we had very good experiences there. So first, a short introduction about me. I'm working at Instagrid since about 1 year, just above 1 year, and I have seen our product develop from the start on, and I've seen all the improvements. My responsibility here was to develop a charging procedure, which includes software as well as hardware development. So what is Instagrid? Instagrid was founded around 2 or 3 years ago by Sebastian Berning and Andreas Sedelmeier in Stuttgart. And since those 2 or 3 years, we have been risen by 30 employees. And we actually also got quite some awards. So what was the idea? Why was Instagrid founded in the beginning? Basically, there's still today, there's about 1.8 billion people working on construction sites day to day. And when they need mobile electricity, is what you can see on the picture is their solution. They take one of these HO diesel generators, which are loud and noisy and produce a lot of fumes into the German word is Schubkarre, and they carry it around. And by the way, the picture is a real life picture that one of my colleagues has taken here in Stuttgart. So we at Instagrid, we believe there is a better solution that's more appropriate for the 21st century. And we have that solution. We have a battery-based mobile electricity unit, which is, in contrast to the product you have just seen, actually mobile. It's just about 15 kilograms, so you can carry it around with one hand. And it does not do any compromises. It offers 230 volts at 3.6 kilowatts. So exactly the same that you would expect from any mains grid voltage. But actually it offers even more. There's up to 11 kilowatts overload capacity. And we build it so that it is durable and reliable. It is meant for construction sites. So it's waterproof, it's dustproof. If you accidentally knock your hammer against it, it won't instantly get damaged. Yeah. So, and we also, this is not just theoretical. We are taking this product on construction sites. Actually, one of our biggest project is, it's called Live Project, where we take 100 units and spread them around the countries in the EU or around the EU on construction sites. And we test it, and we want to improve it more and more and get more and more test results. So you might now think, but that's not too difficult, right? You just take a few battery cells, you slap them together, and you add a DC-AC converter behind. That's not actually gonna work, because if you do that, the DC-AC converter is very focused. So you have a lot of heat production in this DC-AC converter, and you basically can't get around a active cooling. And that's a problem. When you need active cooling, you have a breakthrough in your housing, and now try getting it water or dust proof. It's gonna be quite difficult. So we have a different approach. Basically, we took what is known in very high power applications. On the bottom right in the picture, you can see a person. So it's really big architectures actually. And we made it very small and very low cost. So basically this one big DC-AC unit, we spread it around the whole system. And this way, the heat is also spread around around the system, and we have an easy task of cooling it. So I think I have a very technique-affine audience here. So many of you might have guessed it already. We are talking about a multi-level converter, and this is also where the Nexperia MOSFET comes into place, because you can see on the right side of the picture, there's multiple H bridges, and these H bridges are built by using one, or this is where the MOSFET from Nexperia is used. So this one big DC-AC converter, we have now many small low voltage units. So this is one of these, very small and handy, and they have around 30 volts each. And now they are controlled in such a way that they together produce one big sine wave, some kind of a staircase sine wave. This has some advantages. One of the advantages that now the power management and battery management is just on one, like it's fused together in just one small PCB. And since you have so many steps in the staircase, you're already very close to a pure sine wave. So you need very small filtering. And together with the fact that you now have, or that we use bidirectional H bridges, this means we can directly charge from the grid without too high harmonics. All of this is a very novel and very complex technology. We have more than 20 microcontrollers that need to be orchestrated and synchronized together. And basically we took what was formerly a hardware challenge, and we took that challenge and made a software challenge out of it. So basically we took it into the 21st century. So I hope I have given you quite an idea of who we are and what we are doing. And you're all invited to stay here for the next 10 to 15 minutes and ask Andreas, who's sitting here with me, and me questions. And if that's not enough for you, you can also just follow us on Twitter, LinkedIn, or go on our homepage.
Super, thanks, Jakob. So just to remind everybody, we'll now open to questions. You can ask your question using the orange speech bubble in the bottom right of your screen. We already have a couple of questions that have come in. So how do you achieve a high reliability despite the complexity of the technology?
It's true that the system is more complex and there are more parts used, but that also means we have way higher redundancy. So this is one aspect that we take into account. And another one is that we rely on very high quality products, and we try where possible to stick to the automotive standard. Yeah.
Great, thanks, Jakob. Next question, is there a mechanism to remotely monitor the status of a fleet of batteries?
That is something that we are also already considering. So all of our systems, even now in the state of prototypes, are already delivered with an IoT module. We are using the new narrowband IoT for that. And for the future, so when we roll out the system to the market, each of them will have one of these modules industrialized, and we will offer all kinds of services. So you can think about all of the battery of the insights you want to gain into the battery and how the customers are using them, but at the same time you can start offering services. So we have basically we have requests from large event technology companies to have set up 1,000 units on an Ed Sheeran concert, and you cannot do that without fleet management. So this is something that we will also implement from the start.
Thanks, Andreas. Next question, how fast does the battery charge?
I think that's mine. The battery basically charges from 0 to 100% in less than 4 hours, but it also charges from 0 to 50% in around 1 hour. This is very useful, especially again for craftsmen who have a break, for example, for 1 hour. They want to get in a lot of energy in the system fast.
Okay, next question. What are the key parameters you refereed when you selected Nexperia MOSFETs for the inverter design?
The right person to answer that is probably not here. There are many parameters that we verified. From my perspective, I can say it's especially the experience that we already had with Nexperia. I mean, what the audience doesn't know is that Sebastian and me, so the two founders, came from a large German corporation where we already worked with Nexperia. And so from my side of view, so I'm not the electrician at our side, not the electrics guy. It's especially the basis that you can act on with Nexperia. And you see, we are a startup of 30 people, how Nexperia is treating us on an eye level. And that is certainly something that made us use Nexperia, despite the great MOSFETs that you offer.
Super, thanks, Andreas. How many cycle counts do you have with your product?
That always depends on the application. So none of the battery providers will really tell you a cycle life if it's not really sure what the users are using it to. So if you talk about PV, you can name a cycle life. For us, we usually say it lasts 3 to 5 years. But of course, there will be heavy users that can tear down or wear down your battery within 1 year. But it always depends on your environment. So on the temperature you're working in, it depends on the current you ask for. So how high demanding are your tools? So it's very application specific.
Okay, moving on to the next question. So you mentioned that you can charge the battery with a 230 volt, 50 hertz, but how about other grid voltages such as solar charge or 120 volt AC?
You can basically charge on any grid that's available. Also, I think, for example, for the UK market, sometimes there is 120 volts. So this is absolutely possible, and also DC charging, for example, at cars, or as you mentioned, and solar power. It's all possible.
Super, thanks Jakob. What kind of battery technology is used in your products?
That's we are really using standard. So as Jakob already said, we are trying to get at a very good price performance. That means we try to use commercial off-the-shelf products. So with the MOSFETs, we are not going to 650 volt MOSFETs. Instead of that, we are going to 40 volt MOSFETs. And the same is with batteries. So we are not designing our own cells. We are just purchasing the standard cylindrical cells that go into any Tesla from the large 4 suppliers in Japan and in Korea. And it's standard NCA chemistry, if that means something to anyone.
Thank you. Next question. As there is a BMS kit, how do you manage thermal management and whether BMS is passive cell balancing or active cell balancing?
The heat is just measured, and then there's not really a lot of heat management necessary. Only when charging, there's a limit, so it doesn't get overheated, and obviously there's a emergency shutdown if the unit gets too hot. Apart from that, the cell management is active, so it's always during charging and during discharging. The amount of current each of these modules or each of these levels gets is adjusted to depending on how high it is charged.
Yeah, maybe if I can add on that, it's the efficiency of the system. So we have a much higher efficiency. We are not, like Jakob said, not concentrating the heat generation on one part, but we are spreading that across the entire unit. So passive cooling is the way to go. And also this is due to the Nexperia MOSFETs we are using because they have very good thermal references. And the second thing is certainly we can balancing quite easily. We can do active balancing between the modules because this is what you get for free with the architecture. You can decide when to switch in which module based on temperature, based on voltage, and that makes it quite easy for active balancing within the modules. Of course, passive balancing is more than enough because it's only 6 series cells. And we have a lot of experience in that and know that they are not drifting too much within that small cluster.
Thanks, Andreas. Next question is, are you using swarm battery technology? And can you give some insight into how you've employed it?
Actually, it's a question I'm not sure what is meant with. I think for Jakob that might be the same. We are calling it a swarm inverter. Yeah, so it is a swarm of micro inverters. In each module we have one H bridge, and then we have a central controller, and it's basically operated in a swarm. If that's what the question was about, yes, we're using a swarm inverter.
Okay, and just got time for the final question. It's quite a simple one. Are your products in full running production?
No, they're not. We are in sample stage, but we are very close to full running production. So we will produce out of Hungary, and our production line is close to be finished.
Okay, anything else to add to that, Jakob, or should we close the questions?
I think that's good.
Yeah,
right.
Good. Good stuff. Thank you both very much. So that concludes our live schedule for this morning here on the Industrial Channel. Thank you very much to all our resident power experts. Again, a big thank you to Jakob and Andreas from Instagrid. We do continue our live schedule later today over on the gallium nitride channel. So we'll have discussions on common design issues. We'll be taking a look at our latest copper clip package technology, CC pack, and we'll also have a live panel discussion with our special guest, Ricardo. If you're interested in finding out more about the technology from Instagrid, you can have a look below this video screen. There are further details on the products there and also how you can connect with them direct. So take a look at the schedule for this afternoon on the GAN channel. In the meantime, we do have our full team of power experts available to chat throughout the next 2 days. You can chat to them using the orange speech bubble in the bottom right hand side of the screen. And with that, I'll close this Industrial Live session, and we look forward to welcoming you back this afternoon.